The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, so today we're going to wrap up section 10.4, looking at part 2. Tonight's homework will be to finish 10.4, that is to do part 2 and the chapter review. Tomorrow I'll have a office hour at 10 and then class at 11 where we will review for the test that will be due no later than 11:59 p.m. tomorrow night. Before we go on to finish up section 10.4, are there any questions left over from the weekend that you'd like me to look at first?
I have a question on the part 10.4 part 1. Would you be able to do the 6? I kind of don't get it how you graph it.
Able to do the what?
Number 6 on the
Oh, okay. All right.
Part 1.
Hang on. Just a minute here. Okay. So let me undo the sharing and just do this. Okay. So I got to get out of all this stuff here. So give me a minute. All right. Who's asking? I didn't see who it was.
It was me, because I tried it.
Okay, I see it. I got it. Okay, hang on. Yeah. Okay. And you said which section?
The 10.4 part 1, number 6.
Part 1, number 6. Okay. All right. So. Is that it right there?
Yes, but see, I try and it wouldn't work for me.
Okay, what wouldn't work for you?
Because I was putting 1 and then it keeps on. Can you redo this from the beginning and show me how you do it?
Okay.
Like not on in the whiteboard, but on the actual website. How you plug it in?
Yeah,
I mean that would be helpful.
Let me write this down and then we'll switch over to another place where I can enter it in. Okay, so make a table of values for each function, graph them in the same coordinate system. So you're supposed to graph f of x equals x squared, 4x squared, 1. Okay, all right. So let's do this. And this was 10.4 part 1. Okay. Okay, so can you now see the WebAssign screen over on the left and the whiteboard screen on the right?
Yes.
Okay, super. So we're supposed to graph all 3 of these. So let's start out with f of x equals x squared, okay? And we're going to graph it using table values. Well, actually, we don't even need to do that because we're just going to go straight into WebAssign, right? So I only need a couple of points. But what points do I need? I need the vertex and another point, right?
Yes.
Okay, so let's get rid of all this. I don't need all that. All right. So if we think in terms of y equals a times x minus h squared plus k, this is like y equals 1 times x minus 0 squared plus 0. In other words, the vertex is at 0, 0. Do you see that?
Yes.
Okay. I need one other point. So let's just plug in 1, okay? If
Mhm.
X is 1, 1 squared, Y is 1. So 0, 0, 1, 1 would be, so there's the vertex and one other point. Okay, so there's the graph of f of x equals x squared. You okay with that?
Yes.
All right. So now g of x equals 4x squared. Again, this is like y equals a times x minus h squared plus k. So the vertex is still at 0, 0, right?
Yes.
And when x is 1, y would be 1 squared times 4, which is 4. So 1 comma 4. Are you okay with that?
Yes.
Okay, so 0, 0 and 1, 4. There's the second one. All right.
Oh, okay, now I'm getting it. Okay, I was doing it wrong. Thank you.
Do you need me to finish it, or are you okay with that?
No, I think I got it.
Okay, all right. So let's go back to,
Thank you.
you're welcome. Yes, somebody else?
There was one question that
I can
that was
barely
kind of
hear you.
worded different.
Say that again.
There's a question on that same chapter that was kind of worded different, so it confused me. Instead of saying just graph it, it said graph plenty of points. So is
Graph
that going to
plenty
mean
of
the same?
points.
Yeah.
Okay,
I
let's,
got it at the end, but at first I was trying to graph like just a lot of points and it didn't work, but it was the same as all the other questions.
okay, let's see here. And this was in 10.4 part 1 or part
Yeah.
10.2, what? 10.4 part 1?
Yeah, last night's
And it said graph several points or several graphs.
several points.
You don't happen to know which one it was?
I didn't remember.
Okay. And is this one that you missed, or you ended up getting it right?
At the end, I ended up getting it right, but I got confused because how they worded it.
Okay, well, I guess we could debate whether several could include just 2.
Oh, yeah.
So let's think of several as, and again, in WebAssign, you only need the vertex and a second point. If you were graphing it on a piece of paper at home, then several points, I'd have you plot the vertex and then maybe 3 points to the right and 3 points to the left, kind of thing. But so think of several as just the 2 points as I showed you yesterday or on Friday, Thursday. Okay.
Okay.
So
Okay.
you good to go on that?
Yeah.
All right. Anybody else? Any other questions? All right. Then I'm going to go back to the student view and 10.4 part 2. And let's open this down to here. Okay. So once again, can you see the WebAssign on the left and the whiteboard on the right? Somebody just say yes. Thank you. Okay. All right. So this is a quick review of what we did on Thursday. If we have an equation in the form y equals a times the quantity x minus h squared plus k, the axis of symmetry is at x equals h. And again, I still had some issues with students over the weekend. When it asks for the axis of symmetry, you can't just put a number. You've got to put x equals a number because it's an equation. Okay. The vertex is hk. if A is greater than 0, this thing opens up. If A is less than 0, this thing opens downward. Okay, now we're going to look at equations in another form. Y equals ax squared plus bx plus c. This is the form that typically we put things into when we were using the quadratic formula, except that where the y is, there would be a 0. Okay. When an equation is in this form, the axis of symmetry is at x equals negative b over 2a. And the vertex is at negative b over 2a. So it's the same number that the x value is. And then f of negative b over 2a. What does that mean? In other words, we find negative b over 2a. That's the x value of the vertex. We plug that back into the function to find the corresponding y value of the vertex. And if you're still a little confused, don't panic. We will be going over that today considerably. Still, if a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. This a is going to be the exact same a as if it was in this form. Okay? All right. So let's put this into practice. Let's say we have the following function. F of x equals x squared plus 4x plus 5. All right. It says determine the vertex and the axis of symmetry of the graph of each function. Will the graph open upward or downward? So basically, we're going to do a problem over here, and I'm covering up this problem because I'm going to use the information here, but I'm not doing this. Oh, you know what? It is that problem, coincidentally. So what the heck? Here we go. All right. But usually I just pick one at random in the book, and there we go. Okay, anyway. So for this problem, A is 1 and B is 4. Any questions where I got the 1 and the 4? This is just like if we were going to use the quadratic formula. All right. So for x equals negative b over 2a, that would be negative 4 over 2 times 1, which is negative 4 over 2, which is negative 2. So the axis of symmetry is at x equals negative 2. Okay, so over here, I'm going to put x equals negative 2. Okay. Now, the vertex is at negative 2, comma, f of negative 2. Okay, this is like that notation I used here. What is f of negative 2? Let's see, f of negative 2 is negative 2 the quantity squared plus 4 times negative 2 plus 5. Negative 2 the quantity squared is 4. So 4 plus negative 8 plus 5. 4 plus 5 is 9 plus negative 8 is 1. So the vertex is at negative 2, comma 1. Okay. Negative 2, comma, space 1. Okay. Does the graph open upward or downward? Since A is positive, it opens upwards. So we get that. All right. And there we go. That is correct. You okay with that? Any questions?
Yeah.
Yeah, you're okay, or yeah, you have a question.
Yeah, we're okay.
Okay, great. Sorry about that. All right. Now we'll do another one. And here I'm not, unless coincidentally I picked the same one, I'm not going to do the same one that it was listed there. So I won't click the submit. Okay, let's say we've got this. F of x equals negative x squared minus 6x plus 3. So again, this is in that y equals ax squared plus bx plus c form. A is -1, b is -6. X equals negative b over 2a is negative times -6 over 2 times -1. Negative times -6 is positive 6 over -2 becomes -3. So the axis of symmetry is at x equals -3. So over here in WebAssign, I'm going to put in x equals -3, not just -3, but x equals -3. Okay. Now, f of -3 is negative times -3 squared minus 6 times -3 plus 3. Now, order of operations, we square the -3. Okay, -3 times -3 is 9, but then there's a negative sign in front of it. Okay, then we've got minus 6 times -3, which is plus 18 plus 3, which is what, 12? Okay, so the vertex is at -3, 12. So -3, 12. All right. Does this thing open up or down? Since a is negative, it opens downwards. So we click on that. And again, I'm not going to submit it because that question is not the one I just did. All right. Any questions about that? Okay. Let's see here. There we go. All right. Let's travel back in time to where hopefully in a beginning algebra class, you graphed some linear equations. And when you graphed them, you found points that were called X and Y intercepts. So let's say, for instance, I had the following equation. Let's see, 2x plus 3y equals 6. To find the x-intercept, you set y equal to 0. So you had 2x plus 3 times 0 equals 6. 2x plus 0 equals 6. 2x equals 6. X equals 3. So we said the x-intercept was at 3, 0, which means that on the graph, it would be right here at 3, 0. Okay, any questions about that? So to find the x-intercept, we set y equal to 0. Now, to find the y-intercept, we'd set x equal to 0. So 2 times 0 plus 3y equals 6. 0 plus 3y equals 6. 3y equals 6. Divide by 3, y equals 2. So 0, 2 was the y-intercept. Okay? And once we've got the x-intercept and the y-intercept, we could draw our graph through those two lines. All right. So what's the takeaway from this? To find x-intercepts, set y equal to 0. To find y-intercepts, set x equal to 0. Now let's apply that to a second degree or quadratic equation. Okay. Let's say we've got the following equation or function. F of x equals x squared plus 2x minus 5. Keep in mind, f of x is just another name for y, right? So this is the same thing as if we wrote this function using basic equation notation, okay? So to find x-intercepts, I'm going to set y equal to 0. Okay, so if y is 0, I have this. Well, if you look at that, isn't that the form that we use the quadratic formula on? Ax squared plus bx plus c equals 0. In fact, when we were using the quadratic formula earlier in this chapter, what we were actually finding was the x-intercepts of the graph of that particular function. Okay, we didn't say that at the time. We just said, what are the solutions? We found them, but they are graphically the x-intercepts. Okay, so let's apply the quadratic formula. Let's see, A is 1, B is 2, and C is -5. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals -2 plus or minus the square root of 4 plus, let's see here, hang on. Where did I get this from? You know what I did? These are not going to be nice. You know what? We'll find them anyway. We'll find them anyway. But yeah, I grabbed one that we were supposed to just find the vertex on, but we'll keep going. We'll keep going. Over 2. So x equals -2 plus or minus the square root of 24 over 2. X equals -2 plus or minus, well, let's see, the square root of 24 is the square root of 4 times 6, which is 2 square roots of 6. Did I lose you there? Hopefully not. But then I could reduce this down to that. So our x-intercepts would be -1 plus the square root of 6, comma 0, and -1 minus the square root of 6, comma 0. Now, I did something to you that was mean that the author doesn't intend to do because I grabbed a problem from a different section, but still, these would be the x-intercepts, okay? Any question about that? What would the y-intercept be? To find the y-intercept, you'd set x equal to 0. What's f of 0? That's 0 squared plus 2 times 0 minus 5. So 0, -5 would be the y-intercept. That's right. If you just scribble it, then nobody knows what it really is. So let's go back and do that a little bit better. Okay. All right. So these are the x-intercepts and the y-intercept. Okay with that? Well, and if you're not, I'm going to do another one that has nicer numbers. Okay. Here's the one I wanted. Sorry about that. Again, that was still correct. It was just harder than I was expecting to do for example. X squared minus 2x minus 35. It says find the x and y intercepts of the graph of the quadratic function. Okay, so again, f of x is just another name for y. To find x-intercepts, set y equal to 0 and solve for x. To do that, we use the quadratic formula. So a is 1, b is -2, and c is -35. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay. X equals 2 plus or minus the square root of 4 plus 140. Oops, getting ahead of myself. 140 all over 2. X equals 2 plus or minus the square root of 144 over 2. X equals 2 plus or minus the square root of 144 is 12, all of that over 2. X equals 2 plus 12 over 2, which is 14 over 2, which is 7. X equals 2 minus 12 over 2, which is negative 10 over 2, which is negative 5. So the X intercepts are at 7, 0 and negative 5, 0. So over here, we'd have, let's see, 7, 0. Oh, it's a smaller value. So this would be what? Negative 5, 0, and then 7, 0. Yeah, make sure you read the fine print there, because if you put them in backwards, they're correct intercepts, but you're not following a direction, and then it won't recognize it, and it'll mark them both wrong. So be sure to look everything over. Okay, now to find the y-intercept, set x equal to 0. So f of 0 would be 0 squared minus 2 times 0 minus 35. It's just going to be the c value, isn't it? So the y-intercept is at 0, negative 35. So 0, negative 35. And there you have it. Any questions about that example? All right. Let's give you another example. And again, I'm not going to do the actual one that's on the page necessarily. Let's see, X intercepts. Let's do this one. F of x equals negative x squared minus 10x minus 21. It says find the x and y intercepts of the graph of the quadratic or second degree function. Okay, so again, this is y equals negative x squared minus 10x minus 21. To find the x intercepts, we set y equal to 0. Okay. Oh, I could get rid of that negative leading coefficient, couldn't I? By multiplying both sides by negative 1. So now 0 equals x squared plus 10x plus 21, doesn't it? We okay with that? So now a is 1, b is 10, c is 21, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's see here. So x equals negative 10 plus or minus the square root of 100 minus 84 over 2. X equals negative 10 plus or minus the square root of 16 all over 2. X equals negative 10 plus or minus 4. The square root of 16 is 4 all over 2. So x is negative 10 plus 4 over 2, which is negative 6 over 2, which is negative 3. And x equals negative 10 minus 4 over 2, which is negative 14 over 2, which is negative 7. So the x intercepts would be negative 7, 0, negative 3, 0. And I wrote the smaller one first intentionally. So up here I've got negative 7, 0, and negative 3, 0. Any questions before I go on? All right. To find the y-intercept, we set x equal to 0. So we get that. So there's your y-intercept. So that would be 0, negative 21. I want to mention a common mistake that students make, especially on their tests. Notice the x-intercept is an ordered pair. The y-intercept is an ordered pair. What I'll have students do is they won't put in the 0. They'll just put in -7, -3, -21, and they all get marked wrong. Now, there are contexts in which you can just say the x-intercepts are at -7 and -3, and the y-intercept is at -21, and it's acceptable. But this is not one of them. They're asking for an ordered pair. You've got to put it in ordered pair. Okay? All right. Let's take a look at, let's see here. Okay. Need to find one. Let's go fit here. Okay. This is f of x equals, let's see, 3x squared minus 12x plus 12. It says determine the coordinates of the vertex of the graph of each function, and then determine the x and y intercepts. Okay, and again, I've hidden the actual problem in WebAssign because that's not the one I'm doing. I'm doing the one over here on the whiteboard. All right, let's see, the vertex. To find the vertex, we actually have to start by finding the axis of symmetry. Okay, so x equals negative b over 2a. Let's see, a is 3, b is negative 12, and c is positive 12. Okay. So x equals negative 12 over 2 times 3, which is 12 over 6, which is 2. So that would be at x equals 2. Okay. Now, again, if we were graphing on a regular sheet of graph paper, we would put a vertical line at x equals 2. We're not doing that, so it's not going to look like that, but I mean, on WebAssign, but that's what it would look like. Okay, so now how do I find the corresponding y value? I find f of 2, which is 3 times 2 squared, minus 12 times 2, plus 12, which is 3 times 4, minus 12 times 2, plus 12, which is 12, minus 24 plus 12, which is 0. So the vertex is at 2, 0. Okay. Now, we're supposed to find the x and y intercepts. How do you find x-intercepts? Set y equal to 0. So 0 equals 3x squared minus 12x plus 12. Okay. So we're going to use the quadratic formula to find the x-intercepts. Oh, I could reduce this thing down if I wanted to. You wouldn't have to, but if you don't do it at the beginning, you end up having to do it at the end. I can do it only in this context because it's set equal to 0 and have it help me. Okay, so now I've got what? A is 1, B is negative 4, and C is 4. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals 4 plus or minus the square root of 16 minus 16 over 2. X equals 4 plus or minus the square root of 0 over 2. X equals 4 plus or minus 0 over 2. X equals 4 over 2. X equals 2. Oh, there's only one x-intercept, and that's at 2, 0. So x-intercept at 2, 0, because there's a repeated root. And notice that the x-intercept is also the vertex. Okay. Now, So we've got the vertex and the x-intercept. To find the y-intercept, you'd set x equal to 0. F of 0 is going to be what? 3 times 0 squared minus 12 times 0 plus 12, which is at 12. So your y-intercept is at 0, 12. All right. Any questions so far? I want to go back for just a minute. Right here where I reduced this down in order to get the x-intercepts, I could have just left it as 3, -12, and 12, and then just reduced it towards the end. But we did look at that back in section 10.2. Okay, so to graph this thing, I need 2 points. I click on this till it turns blue. I'm going to graph the vertex. Oh, notice the scale. On this, the scale, each square is 2 units. So 2, 0 is right there, not over here. Okay, now I need to plot another point. Well, I've got the y-intercept at 0, 12. So there you go. So I've got the vertex, the x-intercept, the y-intercept, and I've graphed it using the vertex and one other point. I couldn't use the x-intercept as my second point because it was the same as the vertex. Why do we have just one x-intercept and it's the vertex? Well, anytime the vertex is on the x-axis, it's also going to be the only x-intercept. Any questions on this example? Okay, let's clear all of this out and let's see here. Let's take a look at another example. Let's see. How about, let's see, that only gives us a place to put in one x-intercept. Are there any? Here we go. There we go. That's what I want. So now I can put in more than one x-intercept. F of x equals 2x squared minus 8x plus 6. Okay. So we're going to determine the coordinates of the vertex, determine x and y intercepts, and complete the graph. Okay. So x equals negative b over 2a. And what have we got? A is 2, b is negative 8. Okay, so that's negative times negative 8 over 2 times 2, which is 8 over 4, which is 2. Okay, so the axis of symmetry is at x equals 2. They aren't asking for it, but I find it on the way to the vertex anyway. Okay, now f of 2 is 2 times 2 squared minus 8 times 2 plus 6, which is 2 times 4 minus 16 plus 6, which is 8 minus 16 plus 6, which is what? Negative 2. So the vertex is at 2, negative 2. Okay? So vertex is at 2, negative 2. So in fact, 2, negative 2, there's our vertex. Okay? Let's go back over here and let's find the x and y intercepts. To find the x intercepts, set y equal to 0. Oops. Come back here. So I get 0 equals 2x squared minus 8x plus 6. You know what? This time I'm not going to reduce it down by dividing both sides by 2. Let's just see what happens. Okay. So a is 2, b is negative 8, and c is 6, just like I had over here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a x equals positive 8 plus or minus the square root of 64. 4 times 2 is 8, times 6 is 48, so minus 48 all over 4. X equals 8 plus or minus the square root of, what is that, 16 all over 4. X equals 8 plus or minus 4 over 4. So x equals 8 plus 4 over 4, which is 12 over 4, which is 3. X equals 8 minus 4 over 4, which is 4 over 4, which is 1. So the X intercepts are at what? 1, 0 and 3, 0. Okay, so 1, space 0, 3, space. Notice I put the smaller value first. Okay, now back over here. To find the y-intercept, set x equal to 0. F of 0 equals 6, right? Because all the ax squared and the bx become 0. So 0, 6 is the y-intercept. So there's the y-intercept, there's the x-intercepts, there's the vertex. Y-intercept is at 0, 6, 0, 6. Okay. Now, I've already plotted the vertex. I could plot any of these other points. Let's just do 1, 0. So that's right there. Okay, there's my graph. All right. Any questions about that? All right, I am going to pause the recording, and we're going to share the whiteboard screen. And I want to look at a couple of parabolas. So here is a parabola that opens upwards. The vertex is the lowest point on the parabola. So the y value of the vertex would be the minimum. So let's see, this y value is -3. So y value is y equals -3. So when x is 2, the minimum value is -3. Okay, now here's a parabola that opens downward. So the vertex is the highest point, it's the maximum. And this is located at what? -3, 4. So the maximum would be at y equals 4. Okay, so the maximum value is 4 in this case. The minimum value is -3. So the vertex is made up of two numbers. The first number is the axis of symmetry x value, and the second number is the y that's either the minimum in this case or the maximum in that case. Okay, why all of that? Because these application problems that we're going to look at, they keep asking us to find the minimum value or the maximum value, as we will see. All right, so here's the first problem. It says operating costs. The cost C in dollars of operating a certain concrete cutting machine is related to the number of minutes in the machine is run by the function C of n equals 2.2 n squared minus 66n plus 655. Okay, so the cost C is dependent upon the number of minutes in that the machine is used. Okay. The question says, for what number of minutes is the cost of running the machine a minimum? All right, now, this function is a second degree function. Can you see that? Because of the n squared, okay? The coefficient, that is a, in front of n squared is 2.2, which is a positive number. So if we were to graph this thing, it would be a parabola opening downwards, right? Oh, or would it be? If A is positive, does it open downwards? Nobody wants to say. It opens upwards, doesn't it? Remember, if A is positive, it opens up. If A is negative, it opens down. Well, this is a good thing because they want us to find a minimum, and a parabola opening downward doesn't have a minimum value. So how could I find that minimum value? Well, isn't that the Y value of the vertex? So basically, I'm looking for the vertex. Let's see. I'm going to use X equals negative B over 2A. And I'm going to use X and Y, even though we're actually technically in N and C of N. Okay. So let's see. Negative B would be negative times negative 66 over 2 times 2.2. Okay. Because this is A, this is B. All right. Negative times negative is positive 66 over 4.4. Oh, let's go to the calculator. Let's see. 66 divided by 4.4 comes out to 15. Okay. So 15 is what? The number of minutes. So C of 15 is 2.2 times 15 squared minus 66 times 15 plus 655. Okay, let's see here. 2.2 times 15 squared minus 66 times 15 plus 655 equals, I'm getting 160. All right, so that means the vertex would be at 15, 160. But the question says, where is it here? What is the minimum cost? Now, is the cost the input, in, or the output, C? The reason I'm asking that is because often we get the right information, but we give the wrong answer. Okay, 15 is minutes, and 160 is dollars. That's the cost. So the minimum cost is $160. Okay. Now, for what number of minutes is the cost of running the machine a minimum? 15 minutes. Okay. So run this machine 15 minutes. That's going to produce the minimum cost, which is $160. All right. Any questions about this example? Okay, going on to a new one. It says fireworks. A fireworks shell is shot straight up with an initial velocity of 120 feet per second. Its height S in feet after t seconds is approximated by the equation S equals 120t minus 16t squared. All right, so T stands for time in seconds, and S stands for height in feet. Okay. If the shell is designed to explode when it reaches its maximum height, how long after being fired, and at what height will the fireworks appear in the sky? All right, first of all, let's take this equation and let's put it in descending powers or standard form. Okay. So the leading coefficient, the coefficient of the variable squared term, is negative. So is this going to open upward or downward? It's going to open downward. Okay. So our parabola, if we were to graph it, would look something like that. Now, it asks us to find, it says, if the shell is designed to explode when it reaches its maximum height, so that would be what, the vertex, how long after being fired, so that's time, and at what height will the fireworks appear in the sky? So we want the time and the height of the vertex. Okay, so basically we want the vertex. All right, so let's see. x equals negative b over 2a, and this is what this is going to be a, and this is going to be b. So this is going to be negative 120 over 2 times negative 16, which is negative 120 over negative 32, which is 120 over 32, because negative over negative is positive. And let's go to our calculator again. 120 divided by 32 is 3.75, and that's seconds. So that is the input of the vertex. That's the time at which it reaches its maximum height. Okay. What is its maximum height? Well, we need to plug the time in for t to find s. But again, basically we're finding the vertex. Negative 16, 3.75 squared plus 120 times 3.75. And it's calculator time. Negative 16 times 3.75 squared plus 120 times 3.75. And I'm getting 225 feet. Okay, so how long after being fired? How long after being fired does it reach its maximum height? 3.75 seconds. And then that maximum height is 225 feet. Okay. So again, the answers to the questions was within the vertex. Questions there? All right, let's take a look at another example. A ball is thrown straight upward from the top of a building with an initial velocity of 32 feet per second. So we've got this building, this ball gets thrown. Okay. The equation S equals negative 16 t squared plus 32t plus 48 gives the height S of the ball in feet t seconds after it is thrown. So T stands for time in seconds, S stands for the height of the ball, right? Okay. It says find the maximum height reached by the ball and the time it takes for the ball to hit the ground. So we want to know the maximum height and when it hits the ground. Let me ask you this. Okay, this was not one of the questions in the book, but this is a question I want you to answer. How high is the ball when it is initially thrown off the building? So what's the height right here? Well, consider this. What time is it at the beginning of the problem before the ball is thrown? How much time has gone by? 0, right? If the time is 0, if we put 0 in for t, what is s? It's 48. So this building is 48 feet high. I mean, perhaps a little smaller if you're standing on it and everything, but point is the ball is 48 feet high when it's thrown. They didn't ask that, but it's right there. It's the Y-intercept graphically. Okay, now, but what do they want? They want to know, let's find it again, the maximum height and the time it takes for the ball to reach the ground. We've got a second degree equation. It's in standard form. A is negative 16, B is 32. So x equals negative b over 2a is negative 32 over 2 times negative 16, which is negative 32 over negative 32, which is 1. So x equals 1 would be the x value of the vertex. That's the time it takes to reach the top, right? Because technically it's really t equals 1 second. So how would we find the height? We'd put 1 second back into the equation. S equals negative 16 times 1 squared plus 32 times 1 plus 48. Let's see what that gives us. Negative 16 times 1 squared plus 32 times 1 plus 48 And that comes out to 64 feet. So maximum height equals 64 feet. Now, that occurs 1 second after the ball is thrown. But let's go back. The questions were different from the previous problem. The previous problem, they wanted to know when it reached the maximum height and what the maximum height was. In this case, they want to know the maximum height, but they want to know when it hit the ground. Well, what's the height when it hits the ground? 0. So now we've got this thing. 0 equals negative 16t squared plus 32t plus 48. Oh, we've got a second degree or quadratic equation set equal to 0. So basically, we're going to use the quadratic formula to find the solutions for t, the times at which the ball was on the ground. Okay, well, let's see here. We could tidy this up a little bit and make things a little simpler. Can you see that 16 is a common factor of negative 16, 32, and 48? So I could divide this thing down by 16, but you know what I'm going to do? I'm going to actually divide it by negative 16, because that's going to accomplish two things. It's going to reduce it down, but it's also going to make my leading coefficient positive. So I've got 0 equals 1t squared minus 2t minus 3. Okay. Now, so A is 1, B is negative 2, and C is negative 3. So using the quadratic formula, t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. T equals 2 plus or minus the square root of 4 plus 12 over 2. T equals 2 plus or minus the square root of 16 over 2. T equals 2 plus or minus 4 over 2. So T equals 2 plus 4 over 2, which is 6 over 2 or 3. Or T equals 2 minus 4 over 2, which is negative 2 over 2, which is negative 1. So we're getting T equals 3 and T equals negative 1. But those are times, and time can't be negative, so it's going to be 3 seconds. So let's see, the vertex is at 1, 64. The maximum height is 64 feet. When the ball reaches the ground is at 3, 0, 3 seconds, it's at 0 height. Where's that negative 1? Well, if we extended this graph sort of as a parabola down here, this would be negative 1, 0. But that doesn't literally exist because you can't have negative time, regardless of what science fiction movies may tell you. Okay, at least not yet, we've discovered it. So this doesn't exist, nor is it a correct answer. So back to the answers to the question. Find the maximum height, 64 feet. When does the ball hit the ground? After 3 seconds. Now again, notice that's different from this problem where they want to know how long until it reaches the maximum height, not how long until the blown up fireworks hit the ground kind of thing. So read the questions carefully. Okay, new problem. Before we go on there, any questions on that one? Okay. Suppose you are a police patrol officer and you have a 300-foot long roll of yellow "Do Not Cross" barricade tape to seal off an automobile accident, as shown in the illustration. Okay, so we've got this rectangular yellow tape, and we've got this automobile accident here. And I'm just such a great artist. We've got these cars crunched into each other. Okay, so there's this rectangle, okay? What dimensions should you use to seal off the maximum rectangular area around the collision. And what is the maximum area? Okay, so what do we know? We know we've got 300 feet of yellow tape, okay? And we're going to produce a rectangle. But we want to produce a rectangle that has the maximum area. So consider this. If all four sides of the rectangle equal 300 feet, what if we just considered half of it? So this side and that side. Wouldn't half of 300 be 150? Okay, so here I have sort of representing the two sides that are highlighted black over the yellow. Okay, if those two together equal 150, let's say we call this one X. Okay, if the whole thing's 150, the two sides, and we take away the shorter side, we take away the X, what's left? This would be 150 minus X. Okay, so the rectangle, 300 feet around it, half of it, 150. These two sides are 150. If this is X, we have X, we have 150. Then we take away X, we have 150 minus X. Okay, let's call this the length and this the width. All right, how do you find the area of a rectangle? It's the length times the width. So the area of this rectangle is going to be 150 minus X times X. The area is going to be 150X minus X squared. I'm going to write this in standard form, descending powers. Okay, in fact, let's even use function notation. Let's say a of x equals negative x squared plus 150x. So that is the formula to produce the area of said rectangle. Okay, so any questions how I got to here? Let's recap. I had 300 feet total. I cut it in half to represent two sides. Two sides was 150. If one piece was X, the other was 150 minus X. Multiplied the length times the width to get the area. So the area A of X equals negative X squared plus 150X. All right, now, this is a second degree equation with a leading coefficient that's negative. So we're going to have this parabola that opens downwards. This axis, X, represents the width. This axis, A of X, represents the area. The question said, where is it here? What dimensions should you use to seal off the maximum rectangular area? So we need to find the width and the length. What is the maximum area? So basically, we need the X and the A of X. We need the two values of the vertex. The X value would be the width. The A of X value would be the maximum area. Okay. So what do we got here? We've got A equals negative 1, B equals 150, X equals negative B over 2A, negative 150 over 2 times negative 1, which is positive 75. Okay. So 75, that would be the width. So the length would be 150 minus 75, which is also 75 feet. So our rectangle is not only a rectangle, it's also a square because the length and the width are equal. So what dimensions would produce the maximum area? 75 feet by 75 feet. I should go ahead and use the word by there so we don't have so many X's floating around. Okay. So those are the dimensions. Now, how would you find the maximum area? Well, you'd find A of 75, which is negative 75 squared plus 150 times 75. Let's see what that is. We've got negative 75 squared plus 150 times 75. And I get 5625, and that would be what, square feet? So that's the maximum area. Another way we could find it, since we now know the length and the width, we could just take 75 times 75, which also gives us 5625 square feet. So the dimension 75 feet by 75 feet, the maximum area 5,625 square feet. Any questions about that problem? All righty. Let's take a look at one more. This says maximizing revenue. If you're in business, that's what you want to do, is maximize your revenue. Actually, you want to maximize your profit, but that comes from revenue. It says the revenue R received for selling X stereos is given by the formula R equals negative X squared over 5 plus 80X minus 1,000. How many stereos must be sold to obtain the maximum revenue? So that would be the X. Find the maximum revenue, that would be the R. Well, this is a second degree equation. The leading coefficient is negative, so that means it's going to open downward. So your vertex is going to be your maximum. So this is going to be X, R of X, if you will. That would give you the X value, the number of stereos needed to be sold to maximize the revenue. And the R of X, or R, would be the revenue produced. Okay. And let's see here. So we've got A is negative 1/5. You see where I'm getting that from? And B is 80. So X equals negative B over 2A is negative 80 over 2 times negative 1/5 is negative 80 over negative 2/5. Negative divided by negative is positive. So we've got 80 divided by 2/5, which is 80 divided by 2/5, which is 80 times 5 over 2, which is 400 over 2, which is 200. Okay. So all that to come up with the X value is 200. So number of stereos sold is 200. And that not only means hashtag, it also means number way before hashtag existed. All right, now, how do we find the maximum revenue? We find R of 200. So we put 200 in for X. So R equals negative 200 squared over 5 plus 80 times 200 minus 1,000. Okay. So negative 200 squared divided by 5 plus 80 times 200 minus 1,000. And we come up with 7,000. And that is dollars. So number of stereos sold 200, maximum revenue 7,000. So the vertex would be 200 stereos, comma, $7,000. All righty. So that's it for today. You're going to finish up section 10.4, that is part 2, and do the review questions. Tomorrow we'll review, and then after that you'll take your test to finish by tomorrow night. So are there any questions before we go? All right, well then I'll stop the recording.